This is lesson 8.3, doing binomial multiplication. I'm going to show you 3 different ways that you need to do both the worksheet and then as you work on your homework. You can see the standard is listed up at the top, our content standard, understanding polynomials from a system, knowledge of analogies with integers. They are closed under operations of addition and subtraction, multiplication, add, subtract, multiplying our polynomials together. So the first one you're going to look at, so you should have your notes out. We are looking at a ways of multiplying, and it says there are several kinds of products with binomials, including the models in algebra and tables. One way to find the product of 2 binomials is to use what's called our area model, that's shown below, where they look at an area of one side, this side being x plus 2, this side up here being 2x plus 1. And we're going to do that multiplication, and that's going to be coming up. We're also going to use distributive property, and then we have another special one called FOIL. So if you want to put down in your notes, use distributive properties, the simplest form. What does it mean to simplify? Remember, as you put this problem down in your notes, 2x plus 4 in a parenthesis times 3x minus 7. What we're really looking at as you do these problems is that we want to use our distributive property. So notice as they rewrote the problem, they put down 2x times parenthesis 3x minus 7. Then they're going to distribute the 4, which is the second thing in this parenthesis, times that same next parenthesis, 3x minus 7. Sometimes as we do distributive property, I'll have students draw an arrow to show what they are actually multiplying. So that 2x times the 3x is going to give us, if we are looking at that, 2x times 3x gives us 6x squared. And then taking the 2x times the 7. Negative 7 gives us a negative 14x. Now here we're going to take the 4 times the 3x. 4 times 3x, if we are looking at that one, is going to give us a positive 12x. We're also going to take the 4 times the negative 7, which gives us negative 28. I'd like you to try this one. It says use the simplest form. Simplest form means if you are solving, you at the end want to add your like terms. So our like terms were negative 14x and 12x added to negative 2x, and everything is in descending order. So if we look at the problem, x minus 6 times the quantity 4x plus 3. As you multiply that, first thing you would do as you write out the problem is you would rewrite it as x times 4x plus 3 minus 6 times again 4x plus 3. Again, as you write this out, we are going to distribute. So as we distribute, that means we are taking x times each thing in the first parenthesis. Hopefully at this point you're not having to write that out as 4x times x, but you can write it down as 4x squared plus 3 times x. In this next one, again, now you got to be careful. We're multiplying the negative 6, so not just 6, but negative 6 times both terms in the second parenthesis. So we would now have a negative 24x. And we would then have negative 6 times 3 gives us a minus 18. Could you put plus a negative 18? Yes. Our like terms are usually going to always be our middle terms. So when we add these together, our solution is in descending order, 4x squared. Plus, we're going to take negative 24 plus 3. Negative 24 plus 3 gives us a negative 21x. Could you just have minus 21x? You could. And then minus 18. We don't have any other like terms. This is our solution. I would like you to add one more in your notes to practice it. So if you would put down 2x plus 4 times parenthesis x minus 3. You should pause the video as you're looking at this in class. And right now what you're going to do is you guys are going to do this one, and then as I walk around, I will check that you have it completed. You can pause the video. The next one that we're going to take a look at is when you use a distributive property to multiply, and we're really going to look at it in terms of using a table, or sometimes called the area model. When you look at the problem x minus 3 times 4x minus 5, first off we have 2 binomials, and we are going to be writing them and using a table. So we're going to put the first one going down, x minus 3, the second one going across, 4x minus 5. On the worksheet that you're getting today, the first 1/3 of the problems you need to do with distributive property, showing me like I did the last example. The next ones you need to show a table. So I'm going to always look for your table as we are looking on those next third of the problems on the worksheet that I listed on the board. So as you are taking a look at these, you're going to take x times 4x gives us 4x squared. You're going to take 4x times -3, negative 12x. Negative 5 times x gives us negative 5x. Negative 5 times -3 gives us a positive 15. And what you're usually going to notice is that kind of along your diagonal, so in a way someone says it kind of looks like the lattice method of Ohl's multiplication. You're adding your like terms. That's how we get 4x squared minus 17x plus 15. So again, right now what you're going to do in your notes, we are going to write down this problem, 3x plus 1 times x plus 4. And when it says simplest form, that means eliminate parenthesis, and it also means that you want to add like terms. Does it matter which side you put the 3x plus 1 on? No. We're going to put 3x and 1 going down our table, and then going across our table, we are going to have our x plus 4. Now if it was a negative 4, I'd put the negative in front of it. Usually we don't have to put the plus in front. If it helps you to put it in, put it in. It's not going to matter. 3x times x gives us 3x squared. 3x times 4 gives us 12x. X times 1 gives us 1x, or if you could just write x. 1 times 4 gives us 4. So again, on that worksheet, a third of the problems you will do this method, and I need to actually see the box, not just your answer. So what is my final solution to this one? In descending order, we start with our 3x squared, add along your diagonal, 1x plus 12x gives us plus 13x, and then plus 4. Now, as you look at this problem and you look at the answer, within the next week or so, we're going to start with this question and we're going to move back to this answer. That's called our factoring that I was talking about today as we factored greatest common factor in class. The last of the three methods is, as it says, there's a shortcut used to multiply two binomials. Now this only works with two binomials. It says consider the product of 2x plus 2 and x plus 3. Now here was the box method. 2x plus 2, x plus 3. We had 2x squared, 2x, 6x, and 6. So when we used our box method, it says the area of the large rectangle is the areas of the smaller ones. So when we looked at that, we add the 6 and 2 along the diagonal, and our final answer was 2x squared plus 8x plus 6. It says this model illustrates another way to find the product of two binomials. You find the sum of the products of the first terms. So the F in ours stands for first terms. The O in the word FOIL stands for multiplying the two outer parentheses. So if you think of your outer parentheses, the two numbers that are in the outside parentheses, that's going to be the 2x and the 3. That's our O. When it said first, that was the x and the 2x. That's my first. When I now look at what is the inner terms, inner is the two insidemost terms of each parenthesis. So I'm going to use an I, and I put that in red. And then the last one we're going to take a look at, I'm going to put in green, is for the last two terms in each parenthesis. That's going to be the 2 and the 3. That's our last. So when you look at this, first, outside, inside, last. We're going to do a couple examples of those. When you look at the problem using FOIL, I am now looking at the first, 5x times 2x gives me 10x squared. The outer, 5x times 1. Those are the outside two terms, 5x. The inner, negative 3 times positive 2x. Be careful that you always keep the sign and then multiplying the last of each of those. So that then, again, you are still adding your like terms, and our like terms here are our middle two terms, 10x squared minus x minus 3. So now we have a few problems to practice. It says they want you to simplify and they want you to use the FOIL method. So again, as we take a look at these, we actually want to multiply. So first, outer, inner, and last. So when I look at your work, I should see 3x times x. And then in this case, I'm going to do a plus, and I'm taking 3x times the other outside term would be 2. I'm going to do a plus, and I'm going to take the inside terms. Well, I have a negative 4. Remember, that's plus a negative 4. So I have a negative 4 times x. And then my last one in this one would be a plus negative 4 times 2. My first term is 3x squared plus 6x minus 4x minus 8. Again, can you have plus a negative? You could. My final answer would be 3x squared plus 2x minus 8. I would like you to pause the video, and in class I want you to now try B and C, and after you've paused the video for a while you'll see the solutions. When you multiplied here, your first, outer, inner, and last terms, you should have ended up with this equation. As you simplify, 4n squared minus, as we are subtracting, adding negative 7 and negative 24 would give us a negative 31n plus 42. Try this last one. You're going to see my answer posted in just a few minutes. Again, pause it and you can see that solution before we move on. The last one is you do use FOIL. There are no like terms to add together. So this question asks the two words that are the product of what terms before they combine. The ones you can always add together are your outer and inner. Is the product of two binomials always a trinomial? And the answer to that is no. If you need to pause the video so you can read through this and think about this, you can take a look at that. So pause the video and look at it. If you want to re-watch it, you could. We now want to kind of talk about some of the application problems or the word problems that you're going to be doing. As you are doing those, and we are looking at this one, and it asks you, as you look at this, to which polynomial is in standard form best describes the total surface area. So as you look at the choices, some of you are going, I have no idea. Well, here is our surface area formula. Surface area, and again, the formulas are in the back of your book, is 2 pi radius squared. So that's the area of the base, the circle, pi radius squared, and we have the top and bottom, plus 2 pi times the radius times the height. So notice what they did was they just kept the pi there, but instead of radius, they put in what was our radius, x plus 1. What did they use for the height? They used x plus 4, as you were looking at that. For some reason, my pen's not working. There we go. Height is equal to x plus 4. So every place where there was a radius or a height, they filled those in. Now, when it says x plus 1 squared, remember that means x plus 1 times x plus 1. This example is also in your book, so take a look at it. See how they use the different properties of multiplying the binomials and then combining your like terms. The last thing I want to talk about, because in your homework problems you'll see a few of these. You're going to see something like this where you have a trinomial times a binomial. What do you need to do? Well, this is kind of a multiplication algorithm, but really my key thing that I think you need to keep in mind is you are really distributing. 3x squared times 2x. What does that give us? Negative 21x squared. Oh, excuse me. 3x squared times 2x gives us, as we look at this, the positive 6x cubed. Next, you're going to take 3x squared times negative 7. If we take 3x squared times negative 7, if we look at that, we're going to distribute it. So we have 6x cubed. Then you have 3x squared plus negative 7. So that's going to give us a negative 21x squared. Next thing you want to do, and I'm going to change the color on you, the next thing we're going to look at is taking x times the 2x. When I do that, I'm going to have 2x squared. Notice how I'm lining them up, kind of like they did here. Next, I'm going to take x times negative 7. That gives us negative 7x. Again, as I change color for the last one, I'm going to look at taking the negative 5 times both terms and distributing it. That gives me negative 10x. And the last one would be plus 35. And you're going to add your like terms. It doesn't matter if you do it the way they showed here or here. both answers give you that same solution. Good luck on your assignment. See you in class.